In this presentation, we're going to look at the solutions to the quiz after 5-6. You should have a copy of the quiz in front of you. The first problem asks us to evaluate the definite integral of f of x dx from -2 to 0. Looking at the diagram, we see we need only to view the portion of the graph between -2 and 0. For this solution, we will find a function to integrate and then use the fundamental theorem of calculus to evaluate the integral. The region is defined by a linear function, so we will find the slope and the y-intercept, and then from those we will write a line equation. Then we will integrate the linear function. The slope of the line can be found by the standard rise over run method. The slope is -3/2. The y-intercept is found here at -2. Using these, we can see that the thing we're going to be integrating is the line equation -3/2x minus 2. Put that into integral notation, find an antiderivative, evaluate it first at the upper limit of integration, then at the lower, and subtract those results. The answer is -1. Here is another purely visual solution to the same problem. We need to integrate the pictured function between the two boundaries. Part of the area is above the x-axis, and since we are integrating from left to right, this area is considered positive. Notice that this area is exactly the same as a portion of the area below the x-axis. So the positive area from above cancels with the equal size but opposite signed area below. Now all we have left is area below the curve. This area represents a negative integral. Rearranging some parts again, we see that we have exactly 1 square unit of area represented below the x-axis, so the integral is -1. In question 2, we are to integrate f of x dx from 1 to 0. The first thing to notice is that the area is a 1/2 rectangle, so the area is 2. However, we are integrating from right to left, and so the dx is negative. Meanwhile, the function values are all negative between 1 and 0, so the f of x is negative. Now if we multiply a negative f of x by a negative dx, we get a positive result. Thus, the answer is +2. Another approach to question 2 has us seeking a function rule for f of x on this interval. Since the function is a horizontal line at a height of -2, we can say that f of x equals -2. That's easy enough to integrate. First, we find an antiderivative. Then we plug in the upper limit of integration, then the lower limit of integration, then we subtract the results. Once again, we find the answer is 2. Question 3 asks for the value of the definite integral of f of x dx from 5 to 1. Since we are integrating from 5 to 1, we can regard the dx as a negative quantity. At the same time, the function is always under the x-axis for this interval, so the f of x can be regarded as negative. The product of a negative quantity and a negative quantity is positive, so our integral is going to be positive. This area can be divided into a rectangular region of area 6, and next to that, a triangular region of area 1. Putting these together gives us a total area of 7, and we had determined that the value of the integral is positive, so the answer is positive 7. Another way to look at question 3 has us seeking an analytic solution involving antiderivatives and the fundamental theorem. Now, the entire function can be represented by a piecewise function with 3 different function rules. Since our interval covers only 2 of these function rules, we will focus on those. The rectangular region is bounded by the function in the second function rule, and the triangular region on the subinterval from 4 to 5 is bounded by the third function rule. The integral can be written as the sum of 2 integrals. Replacing the f of x in each integral with the appropriate function rule gives us an opportunity to apply the fundamental theorem. Find antiderivatives, evaluate them, and then add the results, and we get 7. Question 4 asks us to evaluate the definite integral of f of x dx from 1 to negative 2. We can write this as a sum of 2 integrals with the breakpoint at 0, where the function rule changes. Now, this first integral we have already evaluated in question 2 and found it to be equal to 2. Bringing down the second integral, we note its similarity to question 1. Reversing the limits of integration gives us an opposite value for the integral, so we can know that the integral that we're looking for in this problem is equal to 1. Substituting that 1 and adding gives us the answer as 3. Question 5 asks us to find k so that the integral of f of x dx from 3 to k is equal to 2.5, or to explain why it is not possible. Well, it is possible, so we can disregard that part of the problem. Suppose that k is greater than 3. If that's the case, then we are going to be integrating from left to right, and so the dx will be positive. Meanwhile, the function values in the vicinity of 3 are all negative, so f of x will be negative. Now, the product of a negative f of x and a positive dx is going to give us a negative result. But we're looking for a positive result for our integral, so it can't be true that k is greater than 3. In supposing that k was bigger than 3, we saw that that would lead to a negative value for the integral. If we presume, on the other hand, that k is less than 3, then we will be integrating from right to left, and so our dx will be negative. The function values are still negative on this interval, so our integral will be the product of negative function values and negative dx, which will give us a positive result. That's what we want, so let's go. If we integrate as far left as 2, we can see that we'll get an area of 2. But that's not far enough, since we desire an integral equal to 2.5. Integrating as far left as 1 is too far, since it makes our integral have a value of 4. If we integrate to the point halfway between 1 and 2, then we'll add an additional 1 unit of area, which is still too much, since we just need an additional 1/2. With a little bit of thought, you can see that we need to go to a point a quarter of the distance between 2 and 1 to get a quarter of that additional area to the left of our rectangle of area 2. This point is at x equals 1.75, and so that answers the question. Hey, thanks for watching.